While digital drawing tools can create smooth curves from rough user strokes, distinguishing noisy input from intentional detail in strokes is a directive that can only be conveyed by the user. Generating neatened curves that combine smoothness with desired user detail while maintaining the real-time, modeless, and visceral feel of pen and paper sketching is a problem to which there is yet to be a definitive solution. Elasticurves present a novel inertial solution to this problem. By exploiting our natural variations in stroke speed, where smooth portions tend to be drawn quicker than those where precise geometric detail or other design constraints are required, Elasticurves permit both smooth and detailed curves to be drawn using the same primitive. Further, we note that drawing speed is both a ubiquitous affordance we find in all drawing tools, be it finger, mouse, or stylus, and that asking users to define intended precision based on drawing speed is an affirmation of what they tend to do naturally. Elasticurves can be imagined as curves drawn by a pen attached to the drawing implement by a critically damped spring of zero rest length. When a user draws quickly, the Elasticurve spatially lags behind the sketch stroke, smoothing over any fine stroke detail, but quickly catches up and matches the input stroke when the user draws slowly. Responsiveness is an inertial parameter for Elasticurves that controls the mapping from stroke speed to the neatness of the curve. Note that lowering responsiveness increases smooth approximation of the stroke in quickly drawn sections, while preserving detail in slowly drawn parts of the stroke. This allows users to calibrate the system as a function of their drawing ability and the ergonomic inaccuracy of the input device. Elasticurves inertially track the input stroke. In real time, a connector establishes the link between the currently committed Elasticurve and the new point on the input stroke. The Elasticurve then grows by a responsiveness fraction along the connector. Various connectors can be used to model prior knowledge of user-desired shapes. Here, we can see the result of using linear and circular connectors. By default, however, Elasticurves are modeless and defined using circular connectors that can precisely model both zero and non-zero areas of curvature. As Elasticurves grow by a fraction of the connector, they will never reach the cursor position. We remedy this by detecting a pause in the input stroke, which completes the current Elasticurve and restarts another for further stroke input. This also allows cusps and discontinuities to be drawn using the same input stroke with ease. We provide both positional and tangent snapping of the input stroke to allow the creation of closed curves. While Elasticurves form an elegant solution to the real-time stroke neatening problem, we compare it to the results of viable alternatives. Simple neighbor averaging is often used for stroke smoothing in practical systems. While using stroke speed to locally control the strength of this smoothing results in curves that are locally smooth, they do not have global fairness. Input strokes resampled at a fixed distance can alternatively be neatened using Elasticurves where the stroke speed is used to inversely modulate responsiveness. This approach, however, suffers from potential aliasing artifacts on account of stroke resampling. We now present some of the creations submitted by our users. This flower and bird sketch was drawn using a tablet. Note how the bird and flower contrast in terms of detail. Whereas the flower required smooth and fair curves, the bird tended to be much more detailed. Further, notice how by manipulating stroke dynamics, the user was able to sketch both using the same Elasticurve primitive. Here is a sketch where the user chose a mouse as a drawing implement. Users who use mice were especially pleased by the control and flow of the system, as it permitted smoothness and fine detail to be drawn despite their limited motor control and while also resorting to a minimal amount of additional parameters. We also used Elasticurves to oversketch over existing images, where users were particularly appreciative of Elasticurves' real-time feedback. Here, we see an oversketch of a picture of Bob Dylan done using a trackpad. Despite this input device's limited control, notice how the user can still achieve pleasing strokes, matching the image's perceived outline.